Good day, everyone. Welcome back to Math 10 Combined. We're getting a start today on Unit 2, which is called Right Angle Trigonometry. And this corresponds to Chapter 3 of your textbook, although we're not going to be using your textbook for anything at all in this unit. This first lesson, which is dealing with Part 1 of the tangent ratio, can be found on page 1 of your unit handout. And what you're going to need today for part of this lesson is a ruler and a protractor. And if you're in our classroom, you can find a ruler and protractor on the shelving unit where the spare calculators are. There's a bunch of rulers and protractors there, so make sure you have one. What we want to ultimately do today is learn about something called the tangent ratio in trigonometry. But in order for us to learn about the tangent ratio, we need to learn how to label sides of triangles. And we call the three sides of right triangles, and we'll get to what that right triangle means in a second. We call those three sides the opposite side, the adjacent side, and the hypotenuse. So we're going to start off by learning how to label those sides of a triangle, and then we're going to learn about what the tangent ratio is and solve some problems with the tangent ratio. So a right triangle is a triangle that contains a right angle or a 90-degree angle. For all right triangles, we identify the sides, we label the sides with hypotenuse, opposite, and adjacent, but we do so in relation to one of the acute angles in the triangle. An acute angle is an angle less than 90 degrees. So as an illustration, here's a right triangle. I just want to change it so that it's not so symmetrical. That's a right triangle, and the 90-degree angle is usually labeled, but I'm going to just write out that this is 90 degrees. It has to be the case that the other two angles, this angle and this angle, have to be less than 90 degrees. So when we talk about acute angles, we're talking about that angle in that corner and that angle in that corner. A better word to use instead of corner is vertex, but I don't really care about that. So both of those angles happen to be what we call acute angles. And I'm telling you that when we label the sides of this triangle with these three words, hypotenuse, opposite, and adjacent, it depends on which of the two acute angles we are looking at. So to drive that home, we're going to do just a little bit of practice here. On the diagram shown, we have an acute angle labeled theta. Theta is just a Greek letter. Pi is a Greek letter. Theta is a Greek letter. There are tons, well, not tons, there are a large number of Greek letters. And we very often use theta to describe an angle in trigonometry. What we are asked to do is write adjacent, hypotenuse, and opposite for the three sides in relation to theta. Well, I always start with the hypotenuse. The hypotenuse in a right triangle is always the side that is longest. So you can write down that this is the hypotenuse. Then what I do is I talk about which of the sides is opposite. And the word opposite means on the other side from, or across from. And it's opposite to theta. So when you look at this angle here, theta, not the best color choice, but when you look at theta, which of the two remaining sides are opposite to it? Well, that would be the one on the right-hand side of the screen. And then, this is just the way my mind works, if the hypotenuse is the longest side, which by the way is across from the 90-degree angle, and the side on the right happens to be opposite, then the adjacent side must be the bottom side. It's the only one we have left. But adjacent means right next to, and that's why that is an adjacent side. It's right next to that angle. So hypotenuse is the longest side of the right triangle. Or, if you like, it's the one across from the 90-degree angle. The opposite side is the side opposite from the angle, theta, and the adjacent side is the one right next to theta. If you take a look at the next triangle, it's the exact same triangle, but I've moved the angle we're talking about up to the top. And I'm using a different Greek letter, which is alpha. I could have used English letters, but I want you to get used to these different letters. Label the three sides in relation to alpha using the terms hypotenuse, opposite, and adjacent. Well, start with the hypotenuse, which is the hypotenuse, the longest side. I always go to opposite, and now when I look at where the angle is, opposite that angle is the bottom side, which when we used theta, the angle near the bottom, that wasn't the opposite side. And then adjacent is right next to alpha. So what we learn from this is you can't identify which side is opposite and which side is adjacent unless you're talking about a specific angle. If I didn't label alpha in this triangle, and I said which is the opposite side and which is the adjacent side, you cannot answer that. Okay, so now that we know how to label the sides, we're going to learn about a trigonometric ratio, and there are many trigonometric ratios. We're going to learn about 3 of them in this course. We can use a trigonometric ratio to describe a relationship between sides of the triangles that we're talking about and one of the angles in a triangle we're talking about. And one of these trig ratios is called the tangent ratio. The tangent ratio relates one of the acute angles to the sides that are opposite and adjacent. So there's a mathematical relationship between an acute angle and the 2 sides that are opposite and adjacent. And that relationship is this, that the tangent of an angle, so this right-hand side, I just want to write a few things here. This is the tangent ratio of angle theta. And I could rewrite that and I could say tangent of alpha equals opposite over adjacent, or tangent of P equals opposite over adjacent. But we typically use theta. Sometimes we can, when we say what I've highlighted, we can just say tan theta. We don't need to say tangent ratio of angle theta. We can just say, oh, the tan of theta, or the tangent of theta. It's equal to the opposite side length divided by the adjacent side length. So warm-up number 3 continued. What are we asked to do here? Grab a ruler and measure the opposite and adjacent sides. Well, first let's label them. In relation to theta, this is the adjacent side, this is the hypotenuse, and this is the opposite side. I mean, I have more experience with it than you, but I know the hypotenuse is the longest side, the opposite side is across from theta, and the adjacent side is the third side. So what is the length of the opposite side? Now, because I'm on a screen here, I actually measured this and set up the ruler so it's at the same scale as what you have on paper. And when I measure this length in centimeters, it's very close to 3.6 centimeters for the opposite. And when I measure it in centimeters for the adjacent side, it's very close to, I'm going to do a bit of rounding here, very close to 6.7. So it was 3.6 and 6.7. I want to double check that, but This is 6.7. I think this was 3.6, but I'm just going to double check. Yeah, 3.6. So we're asked to measure that and calculate the value of the tangent of theta. So let's see. Tangent of theta is the opposite side length. And this, by the way, is on a formula sheet for you. You don't have to memorize it, over the adjacent. So that means tangent of that angle in that diagram is 3.6 over 6.7. So tangent of theta, according to our measurements, well, we need a calculator. I mean, we're measuring with a ruler, so it's not going to be perfect. It's not like we have a micrometer or some kind of accurate device we're going to use here. It's just a plastic ruler. It's not even incremented very well. So it's about 0.54, we'll just say. It's about 0. I'll put a dot over the equal sign to indicate approximately 0.54. Now, what else are we asked to do? It says your calculator can calculate the tangent of an angle if we know the angle. So we're asked to grab a protractor, measure that angle theta. Let's put my protractor down here on the crosshairs. And I'm looking over here on the right-hand side. I'm looking in this region here. And I can see it goes from 0. I'll try to indicate what it is I'm pointing at here. This is 0 degrees, 10 degrees, 20 degrees. It's not quite 30 degrees. It looks like it's about 28 degrees. 28 degrees. Now let's grab our calculator. One of the things that you need to know is that your calculator can be in different modes. And in this course, anytime we're doing trigonometry, you want your calculator to be in degree mode. So there's a button at the top right beside the second button, which is blue on my calculator, that says mode. And when you hit it, you'll see this set of options. If when you hit it, you're looking at this, where radian is kind of highlighted, you want to make sure you go over to degree and hit enter, and then you can quit out of there by going second mode. So what did we say? My goodness, I forgot. I think it was 28 degrees. I better put it back just to make sure. I think it was 28 degrees. Yeah, it was 28 degrees. So on your calculator, there is a tangent button. You can find it 2 keys above the 9. And if I hit that key and enter 28, what I get is 0.53, which is pretty close to what we got, which is 0.54. Let me write that down. So tangent of theta in our triangle is actually 0.53. If I were to ask you which do you think is right between these two, the 0.53 or the 0.54, I suspect that you would all say 0.53. And the reason for that is we know that when we measure things, you have a little bit of an error. Although we did measure theta, so who's to say where the error is? But these numbers are very close. So the tangent of the angle in this triangle theta is 0.53. I know that's still not meaningful to you. It doesn't mean anything, but just hang on. It will come together in a few minutes. Now, what if we take the same triangle and we do the same thing with alpha? Well, it's the same triangle, so I am not going to remeasure things. This was 6.7 centimeters. This was 3.6 centimeters. But this time, this is opposite to the angle. And this is adjacent. So if we calculate the value of tangent of alpha, it's the opposite side over the adjacent side. So it is going to be 6.7 divided by 3.6, 1.86 approximately. What about if we measure that angle theta and calculate it with the calculator? Let me grab up my protractor again. So now what I'm doing is I'm looking at the bottom of my protractor. I'm looking here. I'm saying that's 0. (10, 20, 30, 40, 50, 62 degrees. So alpha is 62 degrees. Tangent of alpha would be tangent of 62 degrees. Let's see what we get. Tangent, 62, 1.88. And I suppose the lesson to be learned, or one of the lessons to be learned so far is, since we know that we can calculate the tangent ratio on our calculator, don't worry about why we want to calculate it, but since we know we can calculate it on our calculator, we no longer have to walk around measuring lengths of sides. And again, this hasn't come together yet, but it will. So a couple of quick examples. This is just us getting used to using our calculator. What is the value of the tangent of 40 degrees? We grab our calculator and enter tan 40. What about tangent of 15 degrees? We enter tan 15. Now you'll notice that as soon as you hit tan on your calculator, if it's a graphing calculator, you are forced to use brackets. If you have a different kind of calculator at this point in the course, for goodness sake, make sure you talk to me if you're unsure how to calculate these things on your calculator. So this would be the answer to B. I want you to notice that even though we're forced to use a bracket on our calculator, we don't have to write a bracket. So when you look at C, it says tan 85. Well, that's tangent of 85 degrees. That's the answer to C. And the answer to D is tangent of 78. So, I mean, I guess I can write all of these down. How many decimal places? 4 decimal places. So 0.8391. 2679. 11.4301. And 4.7046. And I know, I've already alluded to this, so far, so what? Well, we're getting to the application in just a minute. So that's how we use our calculator to find those tangents. Now, number 2 asks us to explain what that means. Like, what does it mean when you enter tan of 85 on your calculator and you get, I'm just going to call it 11. If you go back, it was 11.4 something, but I'm going to call it 11. It means that 11 is equal to the length of the opposite side to the 85 over the adjacent. And what's important is it doesn't matter how big the triangle is. The ratio of those two sides will always be equal to that number if it's 85 degrees. And that's what we can use to solve problems. Number 3, draw and label a right triangle that represents the tangent ratio shown below. Well, tangent is opposite over adjacent. So you can draw a triangle here, if you want, that has an angle so that the opposite side is 3 kilometers long and the adjacent side is 5 kilometers long. You can draw, if I can grab this thing, there we go. You can draw a triangle where the opposite side is 3 feet and the adjacent side is 5 feet. It doesn't matter. And I'm going to just grab a ruler and show this to you briefly. I'm going to use inches here. So I want the bottom of this to be 5 inches. And I want the opposite side to be 3 inches. You'll see how this is going to come together in a second. And that means that this is the hypotenuse, and this letter is called beta, and this is the angle. This, of course, is a 90-degree angle, and there it is. What's really important here, well, let me fix this first. What's really important is that you understand as long as that angle is the same, the ratio of the sides will be the same. If I take this triangle and I make it smaller, so now it's this triangle, and I'll even change the color if I can. Yeah, sure, why not? Now it's this triangle. That angle is still the same, but the opposite side is shorter, the adjacent side is shorter, but the ratio of the sides will still be equal to 3 over 5. 3 divided by 5 on your calculator is 0.6. So if you measure this opposite and divide by this adjacent, you should get the same thing as if you measure this opposite and divide by this adjacent, because they have the same angle. All I've done is I've shrunk everything by the same factor. All right, now we get into the application. So find the missing side. The first thing we want to do is label all of the sides of this triangle in relation to the 22 degrees. This is the hypotenuse. This is the hypotenuse. X is the opposite side. And 13 centimeters is the adjacent side. Then we write down our formula. I'm going to call it a formula. Tangent of theta equals opposite over adjacent. And I want to pause here and point something out to you. It may seem weird that I think this is important, but it is important for a reason. I do not want you to get in the habit of writing this. Even though this is how it might appear in a textbook where everything is centered. Let me redraw that so it's a little bit better. I don't want you to put it this way, because what we're going to do in a couple of minutes is say tangent of theta over 1. And I want you to get in the habit of having a clean fraction equals a clean fraction, not something that's going to be lopsided. So now what we do is we put in the numbers. I'm going to get rid of that 1 just for the time being. So theta is 22 degrees. We write tangent of 22 degrees equals opposite is x over adjacent is 13. Now, tangent of 22 degrees is just some number. Like if I grab my calculator, I can figure out what it is. Okay? I'm not going to write it down. I'm just showing you that it is some number. Whoops. Tangent of 22 degrees is this number, but it's just a number. So what we have here, everybody, is the same kind of thing we had in the first unit when we were converting. We have a fraction equaling a fraction. So you cross multiply. You say that the product of this and this must equal the product of this and this. So go equals. Well, 1 times x equals 13 times tan 22. And this is how we write 13 times tan 22. We put the number first, and then we write tan 22. Well, 1x is just x, so x is equal to whatever 13 multiplied by tan of 22 is. I mean, you can figure that out. You don't need to draw a triangle to figure it out, because if you want to know the tan of 22, you use your calculator. So 13 times tangent of 22, well, x is about 5.3. About. I think it said round to the nearest tenth. It doesn't say, but I'm just going to tell you round to the nearest tenth. Let's take a look at this one. We label all the sides. We're focusing our attention, everybody, on this angle. So the side that's across from it is the 5, which means this is the opposite. This is the opposite. This is the adjacent. The longest side is the hypotenuse. So we write down, and you'll get used to this. You just have to do more and more, and you'll get used to it. Tangent of theta equals opposite over adjacent. And we can put in the numbers now. Tan of 75 equals opposite, which is 5, over adjacent, which is r. And we are trying to find r. So you have a fraction equaling a fraction. You cross multiply. Listen, I know from experience, years of experience, that students who struggle with this struggle with it because they think they get it, and they say to themselves, I don't need to write it down. I'll just do it in my calculator. I'm telling you that you should write it down. You need to write it down. And I'll come back to that idea in a second. So we cross multiply. What are we doing here? We're cross multiplying. So we're taking top times bottom equals top times bottom. All right, so top times bottom. Tan 75 times r, we should write it as r times tan 75. Listen, there's nothing wrong with writing tan 75 times r, but you'd have to put a set of brackets around it. It's better to write r tan 75. And then multiply the blues. 5 times 1 is 5. Oh, okay. Now we have to get r by itself. And in order for me to do that, I'm going to have to divide by tan 75. Of course, what happens there is these cancel, and you're left with r is equal to 5 over tan 75. And now we can go to the calculator and figure out what that is. 5 divided by tangent of 75 gives me about 1.3 for r. Now, let's just look at this. Does that make sense? Yeah. If that long side is 5, that looks like it could be about 1.3. Keep in mind that triangle is not drawn to scale probably. Now I want to point something out to you. I said I need to see you guys writing all of your work and then cross multiplying. And the reason is that sometimes to find an answer in trigonometry, you end up multiplying. You take a look up here, we're multiplying 13 by the tangent. And sometimes you end up dividing. So if you're just guessing randomly, you'll get it right half the time. Let's try a couple more quick ones. We want to find the value of y. So hypotenuse is here. 12 is opposite. Y is adjacent. My formula is tangent of the angle is equal to the opposite side over the adjacent side. So I can write tangent of 18 degrees equals the opposite over the adjacent, and I cross multiply and I solve. When I cross multiply, I will have y times tan 18 equals 12. 12 times 1 is 12. So I divide both sides by tan 18, and this is how I'm going to arrive at my answer. About 36.9. And again, looking at the diagram, I think that's reasonable. What did I say, 36.9? Yeah, I think that's reasonable. Looking at the fact that this is 12, yeah, that looks like it could be about 36.9. Now we have one more example to do. You're asked to find k, so we label the sides relative to this angle of 62. This is the opposite. This is the adjacent. Uh-oh. This that we're trying to find is the hypotenuse. But the hypotenuse isn't in our formula. What we're going to have to do is find the opposite side with the formula, and then we can use the Pythagorean theorem to find the hypotenuse. So we have tangent of 62 degrees equals the opposite side. Oh, let's just call it O for opposite, over the adjacent, which is 6. And we can cross multiply to find the opposite side. Opposite side times 1 will give us O equals 6 times tan 62. Oh, okay, that's pretty easy. This is the opposite side. Six tan 62 gives me about 11.28. So this is 11.28. We used the Pythagorean theorem a fair amount in the previous unit when we were dealing with slant heights of cones and that kind of thing, and pyramids as well. The hypotenuse squared, which in this case the hypotenuse is k. K squared equals 11.28 squared plus 6 squared. So k squared will equal, I need to take this number and square it and add 6 squared, 163.34-ish. And then, of course, we have to take the square root of that. Let's see, square root of the answer, about 12.8. So k is about 12.8. you know, ish. It doesn't have to be perfect. And I didn't say in any of these questions, but typically we would round to the nearest tenth. You know, I was having a conversation with a student in a different course than this, but the student was getting frustrated because they thought, well, I can't get this. And, you know, if you could be shown how to do something in math by your teacher and then know exactly how to do it all the time, then teachers would all be unemployed. We would just make a video and show it to students once. So don't feel like you're not capable if it doesn't catch on like a wildfire to begin with. That's what I'm there for. And if you come to class, particularly you dual students who should be there anyway, if you come to class and sit at the same table as me, I can work with you and I can make sure that you get this. And you will get it. You just have to try. You just have to work at it. Anyway, I hope that lesson made sense. If you turn to page 4 of your unit handout, it's questions 3, 4, and 5. I think in this printed version of your handout, I highlighted them with little yellow dots so that you can follow which ones you need to do. And that's it. What we're going to be doing in the next lesson, which should be up shortly on my channel, is finding angles in triangles using the tangent ratio. Today was about finding sides. We're going to be finding angles. One final thing, remember, if you have a different calculator, make sure you talk to me if you have any questions about how to use it properly. So, in the meantime, take care and we'll talk to you soon.